We have one problem here, and the problem says check which of the following are perfect cubes. So we have some numbers here and we have to check whether these numbers are perfect cubes or not. And the next part of this question is what pattern do you observe in these perfect cubes? Okay, so you have to keep two things in your mind. First of all, if you notice, these numbers, all these numbers end in zeros, right? So the two things or 2 points that you have to keep in your mind is, the first point is that for a number that ends in zeros, it should have the number of zeros that is multiple of 3. The number of zeros in that number should be multiple of 3. So it should be, if your number ends in zeros, then for that number to be a perfect cube, the number of zeros should be multiple of 3, right? Like if your number is 1000, then it has 3 zeros, a multiple of 3. If your number is 1 2 3 4 5 6, so it is, here you have 3 times 1 is equal to 3 zeros. Here you have 3 times 2, that is 6 zeros, and so on. This is the first criteria for numbers that end in zeros to be a perfect cube. Okay, and the second point is that the number formed by the remaining digits should be cube numbers itself, right? Number formed by the remaining digits, that is the digits other than zeros, remaining digits should be cube number itself. Only then your number will be a perfect cube. Okay, let's check. So your first number is 2700. Here it is 20. We have 2 zeros, so it's not a multiple of 3. Ignore it. Then we have 16,000. Okay, we are checking only first point, not the second point. So here we have 3 zeros, that is 3 multiplied by 1, that is equal to 3. So it's a multiple of 3. Let's take this. Then we have 64,000. Again, 3 times 1 is 3. We have 3 zeros, 64,000. Then we have 2 zeros, ignore it. We have again 3 zeros, that is 3 times 1 is equal to 3. So 1,25,000. Then we have 36,000. Yes, take this. Then we have 21,600, 2 zeros, ignore it. We have 10,000, 4 zeros, not a multiple of 3, ignore it. Then you have 27, and then we have 6 zeros. So 3 times 2 is 6. Okay, let's consider it. 27, and then 1 2 3 4 5 and 6. And then we have 1000. So 3 times 1 is equal to 3. Yes, consider it. Okay, so we have checked this first point. Now turn for the second test, whether the number formed by the remaining digits is cube number or not. In this case you have 16. Is 16 a cube number? No, 16 is a square number, that is 4 squared is equal to 16. Therefore this is not a cube number. Now you have 64, the number formed by the remaining digits, that is 6 and 4. Yes, this is 4 cubed. 4 cubed is 64. Therefore this number is a perfect cube. Here you have the number formed by the remaining digits is 125. Is it a perfect cube? Yes, this is 5 cubed is equal to 125, right? So basically this whole number is a cube of 50. 50 cube is what? Is 1,25,000. In this case, this is a perfect cube of what? Is of 40, right? 4 from here, and this is 40 cubed. So 40 cubed is 64,000. Here in this case, since it is not a cube number, so ignore it. Here it is 36,000. We have 3 zeros. The first condition gets satisfied, but this 36 is not a cube number. This is a square number. 6 squared is 36. Okay, here we have 6 zeros. Okay, but this number 27, is this a perfect cube? Yes, this is a perfect cube. This is 3 cubed is equal to 27. So this number is a perfect cube of 300. 300 cubed. So if you find the 300 cube, so this is what? 3 times 3 times 3 is 27. Then we have 2 zeros. So 3 times 2 is what? 6. So we have done all these things. How do we write? Like 2, 3, 4, 5 and 6. Okay. What about this one? Here we have 1. Yes, 1 is a cube number. That is 1 cubed is equal to 1. And this is a perfect cube of 10. 10 cubed is equal to 1000. That is cube of 1, and then we have 1 0. So 3 times 1 is, we have 3 zeros here. So this is the way to find the answer, and this is a pattern that we observe here. The answer of the next part of this question is actually this one, and which all numbers are perfect cubes are here.